Hi, my honors super chemist out in King William County. It's Tracy Folks live from King William High School, ready to talk to you about our lecture from day one. And this is just a recap of it in case you need to hear it again because you're home and you're doing some work and you just need to go over a couple more problems. So I'm basically going to hit all the points I hit in class. I am looking at your Unit 1 math unit notes, which are in Schoology. Okay. If you look at them, the first slide talks about types of observation. And you guys really already know that from middle school because you had some great middle school science teachers. And there's two types of data we talk about in science. There's qualitative and quantitative. Quantitative is numerical. It always has numbers. Qualitative does not have numbers. It's things like colors or shapes or things like that. So if we're dealing with data that has numbers, which is generally what we do in chemistry, it's going to be quantitative. And again, most of you guys already knew that because you had awesome teachers in middle school, okay? Or before you got to me here at the high school. Now, the next slide in your notes talks about scientific notation. From math class, they called it exponential notation. All of you guys did really, really well in this, so I'm just going to go over these fairly quick. Basically, at this point in your super chemist career and your math career as a student here, you should be able to put numbers into and take numbers out of scientific notation. So, for instance, okay, you have this big number here. There's no decimal. So the first thing I do is write a decimal in. And then I'm going to move that decimal until I reach a number that falls between 1 and 10. So, bloop, 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 bloop. I end up at 2.8. 2.8 is a number that falls between 1 and 10. And then I write my times 10 after it. And the exponent there is going to be how many times I had to move my decimal to get to 2.8. So I moved it 1, 2, 3, 4, 5, 6, 7 times. That 7 is positive. Now, I'm going to scratch through that. I want to get to this negative exponent here. When I see a negative exponent, that means that original number was really tiny. It was a decimal number. It means I have to move my decimal 6 times, but this time my decimal is going to the left side. I'm going to make a small number. So, 1, 2, 3, 4, 5, 6. I put my decimal there. What do I put in my little divots or my little things that I just drew? Zeros, that's right. So everywhere there's a little divot, I put a 0 in. And so when you go to really record this number for me to show me that you know what you're talking about, it's going to look like this. Okay? And all of you guys were pretty good with that in class, so I'm not really worried. We'll do a couple more and then we'll move on, okay? Here's my decimal here in the next one, and these are the same examples that are in your notes and the same ones we did in class, kind of beating a dead horse. I'm going to take this decimal and I'm going to move it until I get myself a number between 1 and 10. 1, 2, 3. Moved it 3 times over to get 2.01. That is certainly a number that falls between 1 and 10. Times 10. Moved it 3 times, but because this number was super tiny, it was a decimal number, that 3 over there is going to be negative to communicate to me that that's a tiny number. Okay? Last example I'm going to do with you is this one. I have to draw my decimal in. I move it over 2 times to get my number that is between 1 and 10. There it is. And this is times 10 to the 2. That 2 stays positive because that's not a tiny itty-bitty decimal number. Okie dokie artichokes? All right, so that's scientific notation in a nutshell. And you guys got that in math class and science class way before you came to me because you're the honors kids. You are the gifted class. So you are good to go. All righty poo. Now, we are moving on to the biggie in chemistry this year. And that is dimensional analysis, okay? We do all sorts of conversions with the metric system, with English units, all sorts of things, okay? So, I want you to find this slide that says units and measurements in your notes. It's the next slide over. And we talk about the metric system. You know, everybody in the world uses metric except for us, okay? So we'll talk about some metric conversions, and then we're going to have to be able to convert our English units into metric units as well, okay? Kind of mathy, but I know you guys are going to love it, and it's going to be super easy for you. Now, on this slide, it talks about base units, okay? Back that mass up. Mass is always in grams, okay? Nothing new. Length is meters. That should not be new to you. Time is seconds. You know, in chemistry, things happen really, really quick, so we might start talking about nanoseconds. Temperature was that crazy K, which stood for Kelvin. We'll go over that in a little more detail towards the end of these notes on another day. Volume is liters. You should have heard of liters before. The new crazy poo is the one that's on the bottom, is amount of substance, or moles, okay? And we'll really dive into that in about a month or so, okay? Now, the one thing I made you write with a happy cloud on this page in your notes was this. So I'm drawing my happy cloud, and I shouldn't even have to tell you because you wrote it in the happy cloud in class, and you are good to go. 1 inch equals 2.54 centimeters. And that is going to be so important for us because when we go to the doctor's office and get measured, we get measured in inches and feet. We really don't get measured in meters, things of that nature. So we're going to want to convert back and forth from that. You need to know this forever. You need to memorize this. The happy cloud, 1 inch is 2.54 centimeters. Okay, enough said there. So let's dive into some conversions. Now in your notes, we before we did conversions, we talked a little bit about prefixes because there's all sorts of prefixes in the metric system, okay? And there's prefixes that you just have to memorize. So if they don't click right away, you're going to need to make some note cards because this is like gum on your shoe. It's not going anywhere. It's with you for the whole year. So there's all sorts of prefixes that you probably already came into my class knowing, and a few that I'm going to teach you this year. So mega and kilo are biggie, okay? And they are bigger than the base unit. They are a little crazy poo. So for instance, if I have 1 megagram, I really have 1,000,000 grams. So mega means million, all right? Kilo, you probably heard kilo way before you came into my class. 1 kilogram equals 1,000 grams. Okie dokie artichokes. Now everything else, all of those other prefixes on your handy dandy notes, they're tiny. They're smaller than the base unit. So the first one there is deci. And when I think deci, I think dime. Deci, dime. Deci, dime. Okay, the next one is centi. Centi is 100. That's super easy to remember because there are 100 years in a century. And you probably knew centi before you got to me in this class. Milli is 1,000 because there are 1,000 years in a millennium. Okay? After milli, there's micro. And you know, I didn't put abbreviations beside them, and I should go back and do that for you. Mega is capital M, kilo is K, deci, centi, milli. Micro is million. There are 1,000,000 micrograms in 1 gram. And micro had that crazy poo symbol. It was like a cursive U. That's what it looked like. Okay? So micro is a little crazy poo. And you couldn't use a lowercase m because you already got that for milli. You can't use an uppercase M because we already have that for mega. Okay, next. Nano. Doesn't that just sound small? Nano, lowercase n. When I say nano, you say 9. Nano, 9, nano, 9. So nano is always 1 times 10 to the 9. And the last one, which is also probably a new one for you guys, is pico. And remember our little cheer. When I say pico, you say 12. Pico, 12. Pico, 12. Okay? So, Shazammy poo-poo. Again, if you need to make flashcards to remember these, Whatever helps you to memorize them, you need to do it. These aren't going anywhere. You will be doing these the last day of school with me. Okay? So muy importante, that means very important from a non-Spanish speaking peeps. Okay? Got to learn those. Alrighty, poo-poo. I am moving to the next page in your notes, and I'm going to do a handful of conversions with you. Again, I'm not going to do every single one. Not going to beat that dead horse, but I'm going to do a handful with you to kind of get you going. I'm looking at the next slide that says dimensional analysis. Okay, I'm going to start with number 1 that says 300 centimeters to meters. Because I am a super chemist, I always take what's given and put it over. That's right. So I have 300 centimeters over 1. I don't want to be in centimeters, so I draw xy poo poo in a line. I want to get rid of centimeters. Anything I want to get rid of goes on the bottom of the next step. Okay, so I'm getting rid of centimeters, it goes on the bottom. According to number 1, I want meters. So whatever I want goes in the top or in the numerator. Now, because I'm a super chemist and I have memorized all of my conversions, I look at these. What's bigger, a meter or a centimeter? A meter is bigger, and the biggest unit always gets a 1. How many centi in anything? How many years in a century? Century will always get 100. And the beauty of this and why it's called dimensional analysis is because anything that's on the top and the bottom can cancel out. So, centimeters on the top, centimeters on the bottom, it cancels out. Multiply across the top. 300 times 1 is 300. 1 times 100 is 100. Top divided by bottom. Now, I know this one was super easy. They will get more complicated, but I just wanted you to kind of see how that goes. Now, I am moving on to example number 3 on this sheet. 567 picometers to kilometers. Take what's given, put it over 1. I want to get rid of picometers, so where does that go in my next step? On the bottom. Can I go directly to kilometers? No. I have to go to the base unit. Oh my goodness, I forgot my base units. Well, I will cheat, okay? Because Mrs. Fulks has taught me how to cheat. So I cover up that first letter, and I can see that my base unit is meters. So that's where I have to go. Who's bigger, a meter or a picometer? A meter's bigger. So the bigger unit gets a 1. When I say pico, you say 12 pico, 12 pico, 12. So pico will always, 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 did I say always? Always get 1 times 10 to the 12. Okay? I'm in meters. I don't want to be there. Xy poo poo. Get rid of them by putting them on the bottom of the next step. In question number 3, I was asked for kilometers. Okay? So I'm going to put that on the top. Who's bigger, a kilometer or a meter? A kilometer just sounds bigger. So it gets a 1. Bigger unit gets a 1. How many meters in a kilometer? Kilometers always have 1,000 base units. So 1,000 meters in a kilometer. Meters cancel. I multiply across the top. Shazammy poo poo. I multiply across the bottom. I plug and chug into my calculator. Shazammy poo poo. There it is. Now, I'm going to link up a second video to get you through a couple more of these problems, so you are going to have to watch 2 of them if you're looking at the lecture for today. But I really hope it helps, and I miss not seeing you in class, and I can't wait to see you again. Make sure you watch part 2 of this video. Toodles poodles.